projects. In this video, we are going to explain about a project titled Student Placement Prediction. The project explores the hurdles encountered by the higher educational institutions when striving to enhance the student placement outcome. To tackle these challenges, the proposal suggests employing the machine learning technique to extract the valuable insight from both the operational and historical data within the institution database. Specifically, the project advocates the utilization of the Neobase and the KNN machine learning modules to forecast the placement status of the student based on the past record. This predictive capability stands to benefit the students, educators, and the placement cell within the institution by enabling the targeted support to enhance the student performance. A strong placement record is paramount in establishing a favorable reputation for an educational establishment. And the primary goal of this project is to present an innovative machine learning approach that can effectively forecast the placement outcome of the student within the higher educational institutions. To achieve this objective, the project proposes the utilization of Neobase and the KNN machine learning modules, leveraging the past data to make the accurate prediction. Such forecasts hold the potential to be immensely valuable as they can enable the student, teachers, and placement cell to tailor the targeted support and intervention to enhance the student performance and the career opportunity. By emphasizing the significance of achieving a high placement rate, the project underscores how this crucial metric directly impacts the reputation and standing of an educational establishment. Ultimately, by harnessing the power of machine learning, the project seeks to optimize the placement performance of the student and contribute to the overall success and prestige of the institution. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And these are the steps we need to discuss about the flow of the project. The first one is importing the library. In this step, the necessary Python libraries are imported to facilitate the data handling, pre-processing, and the model building. NumPy for numerical computation, Pandas for data manipulation, Matplotlib for data visualization, and sklearn for machine learning algorithm. And the second is importing the dataset. The dataset containing of various attributes related to the student academic performance, background, skills, and the placement status is imported. The dataset consists of columns like serial number, secondary education percentage, higher secondary education percentage, undergraduate percentage, and of many more. And the third one is feature selection. In this step, the relevant features are chosen to build the predictive model. The selection is based on the significance of the features and the influencing the placement status. Features that are highly correlated to the outcome and contribute significantly to the prediction are retained, while irrelevant and redundant features may be excluded. And the next step is building the model. Here, we are building the model by the two algorithms. The first one is Neobase. It leverages the selected features and the corresponding placement status label for training. Neobase is a probabilistic classifier that assumes the independence among the features, making it computationally efficient and suitable for the large data set. During the training, the algorithm estimates the probability for each feature occurrence within each class, placed or not, F then applies the Bayes theorem to calculate the conditional probability and make the prediction. By learning the pattern and the relationship between the input features and the placement outcome, Neobase can efficiently predict the student placement status based on the provided data. And the second one is K-nearest neighbor classifier. Here, it built to predict the student placement status. This instance-based learning algorithm classifies a new data point by considering the majority class of its k nearest neighbor and training data. The algorithm relies on the distance metric, typically the Euclidean distance, to find the k nearest neighbor. It uses the selected features and training data to create a stored representation of instances and their class label. During the prediction, the k neighbor classifier identifies the k nearest neighbor to the new data point and assign the most frequent class label among them as a predicted placement status. The model simplicity and the effectiveness make it a valuable addition to the prediction process. And the next step is accuracy comparison. Both the model accuracies are evaluated and compared using the suitable evaluation accuracy metric. This step helps in understanding which model performs better for the given dataset and the task. And the next step is training the model. Here, once the preferred model is selected, based on the comparison result, it is trained using the entire dataset to capture the overall pattern and the generalize well on the unseen data. And the next step is user gives the data input. Here, a web application is created using the Flask framework to make the input from the user. The user is prompted to provide the academic information and etc. The next step is the given input is pre-processed for prediction. The user provided input is pre-processed to ensure it aligns with the format used during the model training. This step involves data cleaning, transforming the categorical variables into the numerical format, and scaling too. And the next step is trained model is used for prediction. The pre-processed user input is fed into the trained model to predict the placement status of the student. And the last one is final outcome is displayed. The predicted placement status for the user is presented through the web application. It indicates whether the student is likely to be placed or not based on the input data and the model prediction. And the execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of various files within it. The dataset folder containing of the dataset that is used in this project, and the template folder containing of the HTML files within it. And the app is an py file which contains the information related to the front-end logic. It includes the code written in the Python that handle the server-side operations such as processing the user request, generating the dynamic content that to be rendered in the HTML template. And the model is an pickle file that contains the algorithm information is loaded into the project code during the runtime to utilize the trained model for the various tasks such as making the prediction on the new data or performing the specific operation. And student placement prediction is of IPYNB file which contains the combination of the code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And for the execution of the project, we need to copy this code folder path. And mainly the total code is present in the IPYNB file as the combination of the code, graph, output all in one place. And open the Anaconda prompt. Here first we need to change the location of the disk to F, and here we need to write a command that is cd space and paste this code folder path. By this it will change the location of the disk to the code folder path. And we need to write another command that is python space app.py. By using this command, it will execute the Python script and perform a runtime check for any syntax errors or the logical issues. And then click on enter button. By this, app.py file will run and the Flask framework will host the application locally at the default address like this. We need to copy this address and paste it on any of the web browser of our choice. I prefer to use the Chrome. And paste this local link and then click on enter button. Here we redirected to this page containing of some details within it. And we need to mention a male or female, and I'm mentioning the female, and we need to enter the 10% as of 95 and the 12% is of 87 and the graduation percentage too. And before that we need to specify it's the 10th board is of central board or other board. and its center board, and the 12th is of other board or center board and it is central board. And the graduation percentage too we need to enter as of 82, and then click on the submit button. Here we can predict the answer. You are doing well, you will get placement. And then press on back button and refresh button. Here we can enter the other detail as of sex as male, and the percentage of the 10th is of 49, and the board is of central board, and the 12th percentage is of 53, and the board is central board, and the graduation percentage is of 54, and the graduation specialization is commerce and management. And then click on graduation specialization is of science and technology, and then click on the submit button. Here the predicted answer is work hard, chances are less, so improve and see. And this way we can predict the answer by giving the input detail and giving the feedback for the student to get the placement. And here this is the comparison graph with computer accuracy, where x-axis represents the score of the accuracy of each algorithm used in this project, and the y-axis shows the algorithms we used in this project. And in conclusion, the project proposed a machine learning based approach to predict the placement status of the student in higher education institution. The proposed approach uses the Naive-Bayes and the k-nearest neighbor machine learning model to predict the placement status of the student based on the past data. The project suggests that the prediction of the placement status can help the institution to improve the performance of the student and achieve a high placement rate, which is essential in building the reputation of the educational institution. The proposed approach is expected to provide the more accurate result than the previous research project that have focused on the limited number of parameters for the placement status prediction. Overall, the project concludes that the proposed approach can be a useful tool for the institutions to improve their placement performance and enhance their reputation.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.